This video is on using the distributive property to simplify rational expressions, and it's lesson 39 in your book. So a rational expression is an expression with a variable in the denominator. Now notice the word rational here, which starts with the word ratio. It means you're dividing two things, and in this case you're dividing by some variable. Rational expressions can be treated just like fractions. So even though there's letters in them, they're still just fractions. Remember, the denominator cannot equal 0. So whenever we simplify a rational expression, we need to qualify our answer with the fact that the denominator cannot equal 0. So at the end we'll have to put something like x does not equal 0 and y does not equal 0 or something like that. And variables stand for unknown real numbers, so we can still use all the properties of real numbers, including the distributive property, to simplify them. Alright, so here's our first example, and this needs to be in your notebook. We want to simplify x squared over y squared times the quantity x squared over y plus 3y to the third over m. Now, notice that we have something outside the parentheses, and then an expression inside the parentheses. And we're going to use the distributive property to multiply these. Now, I need to multiply x squared over y squared by each term inside my parentheses, just like the distributive property tells me to do. So now I've got x squared over y squared times x squared over y, because that's my first term. So I've done this term times this one, then plus. Now again, I've got to multiply x squared over y squared by that second term, so x squared over y squared times the second term, 3y squared over m. Now once we've distributed our outside factor, which in this case is x squared over y squared, we need to simplify each term individually. Now, notice that this first term involves two fractions being multiplied, two rational expressions. We can treat them exactly like fractions, and when we multiply a fraction times a fraction, we multiply top times top, numerator times numerator, and denominator times denominator. So we're multiplying x squared times x squared over y squared times y. Then we've got plus. Now same thing for the second term, x squared times 3y squared over y squared times m. Now we need to simplify. Now remember, if you're multiplying like bases, like we are here, x squared times x squared, you can add their exponents. So then, that actually gives us x to the fourth. Over, now we've got y squared times y, like bases, so we can add their exponents. 2 plus 1 is 3. So that's y to the third. And we've got our plus. Now here we've got x squared times 3 times y squared. Now, x squared times 3 would be 3x squared. Notice here that we have y squared divided by y squared, so y squared on the top and y squared on the bottom. And when we're dividing like bases, we subtract their exponents. So y squared divided by y squared would be y to the 2 minus 2, or the 0th power. So essentially these cancel out, and all that we're left with on the denominator is m. Now we have to make sure that this is in proper form, so we have x to the fourth over y to the third plus 3x squared over m. And none of our exponents are negative. We don't have more than one of the same term, so like we don't have an x to the fourth in this term and then maybe another x squared in the same term. So this is our simplified answer. Now remember that that last slide said that the denominator cannot equal 0. So now we need to specify which variables cannot equal 0. Now, notice down here y to the third is the denominator. So that means y to the third cannot equal 0. So what number could we plug in for y and cube that would make 0? Well, that would be 0. So we also have to say, as part of our answer, that y cannot equal 0. Now notice m is also a denominator, so we also need to say m cannot equal 0. And this is part of our answer. It's an important part of our answer. So you do need to include that when you're doing your practice. Alright, here's our next example. A few more variables here. This again needs to go in your notebook. So we want to simplify m over z times axp over mk minus 2m to the fourth p to the fourth. Okay, so remember, we definitely are going to have to distribute. We have a factor outside the parentheses and then two terms inside the parentheses. And remember before, when we multiplied these things, we multiplied top times top, bottom times bottom. So I'm going to make this term right here into a fraction by putting it over 1. Now again, I didn't actually change anything. I just made it look prettier for later. So I need to multiply m over z times the first term. So I have m over z times axp over mk minus, now I also have to multiply m over z times my second term. So m over z times 2m to the fourth p to the fourth over 1. Now, in order to simplify this, I'm going to have to simplify each term separately. So I'm going to have to multiply m over z times axp over mk, and it's a fraction. So I multiply numerator times numerator, denominator times denominator. So I've got m times axp over z times mk. And I've got my minus. Here I have m times 2m to the fourth p to the fourth over z times 1. Now I simplify. So m times axp would be maxp. Now notice that I have an m in the numerator and an m in the denominator. And so I'm dividing like bases here. And both our exponents are 1. So I can do m to the first divided by m to the first is m to the 1 minus 1, or m to the 0th power. So those cancel. Now we have no other like bases in this term. So we're just left with axp over zk. And we've got our minus. Now over here I have m times m to the fourth, like bases that I am multiplying, so I can add their exponents. So this is like m to the first. So m to the first times m to the fourth is m to the 1 plus 4, or m to the fifth. So I've got 2 m to the fifth. I don't have any other p's or z's, so p to the fourth over z times 1, which is just z. Now this is my solution. Remember, I also have to say what numbers cannot equal 0. So the denominator cannot equal 0. So the denominator here is z. So that means z cannot equal 0. Now here we've got z times k. Now if z was 0, that would make the whole denominator 0. But if z was not 0, then k was 0. That would make the whole denominator 0. So we also need to say that k cannot equal 0. And that is the other part of our solution. Alright, here we've got another one. Notice we have some negative exponents here. Now, the problem still goes the same. We still do all the same steps, except we have to deal with those negative exponents. So I still need to multiply b to the third over d to the negative third at each term inside these parentheses. I'm still going to have to distribute. Now I actually have two options here. I can go ahead and distribute right away, or I can simplify everything first by getting rid of those negative exponents and then simplify. So I'm just going to go ahead and distribute without simplifying. So I'm going to multiply b to the third over d to the negative third times this first term. So b to the third over d to the negative third times the first term, which is 2b squared over d. and I've got minus, because that's my sign right there. And then I'm going to distribute b to the third over d to the negative third to that second term. So b to the third over d to the negative third times f to the negative third d over b. Alright, so now we'll simplify each term individually. So I've got b to the third times 2b squared. Now, b to the third times 2b squared, I've got b to the third times b squared, so I can add their exponents because I'm multiplying them. 3 plus 2 is 5. So my numerator here is 2b to the fifth. Now in my denominator, I have d to the negative third times d to the first. I'm multiplying these two things, so I can add their exponents. Negative 3 plus 1 is negative 2. So I've got d to the negative second power. Over here I have b to the third times f to the negative third times d, and then I've got d to the negative third times b. Now, see how I've got b to the third on top and b to the first on bottom? I'm dividing like bases here, so I can subtract their exponents. b to the third divided by b to the first is b to the 3 minus 1, or b to the second power. Now I've got f to the negative third, and that's my only f, so it stays the same. And then I've got d to the first divided by d to the negative third. Those are like bases, and I can subtract their exponents. So 1 minus negative 3 is really adding 3, so I actually have d to the fourth. Now notice that this is not simplified because I have some negative exponents here. In order to make those negative exponents positive, I have to move them to the other side of the fraction. So here where d is to the negative second, I'm going to have to move that into the numerator to make it a positive exponent. So I have 2b to the fifth, and then d to the negative second comes up to the top to become d squared. Then I've got minus. Now here I have f to the negative third. Since it's negative in the numerator, I'm going to have to move it down to the denominator. b squared and d to the fourth are going to stay where they are in the numerator, and they're going to be over f to the positive third. Now this is part of my solution. The other part is to say that the denominator cannot equal 0, so f to the third is in the denominator. Now the only number that I could plug in for f that would make that denominator 0 is 0. So f cannot equal 0. Alright, and then one last one. We're going to start it, but we probably won't finish it, is this example. Now, notice that I actually have 3 terms in my parentheses here. The process is the same. However, you have to multiply 3 times instead of just 2. So I have to multiply ab over c squared times each term in this parentheses. So ab over c squared times axb over c. Then there's a plus, and then it's ab over c squared, and I have to multiply that by 2bx. Now I'm going to put that 2bx over 1 just to make it a little easier to see that we're still multiplying by a fraction. And then there's a minus, and then ab over c squared times that third term, which is 4 over c squared. Now, remember you're multiplying numerator times numerator, denominator times denominator. So you've got a times a, which is a squared, b times b, which is b squared, and then there's an x, all over c squared times c, and when I add their exponents I get c cubed, plus a, and then there's a 2 out front, b times b would be b squared, then there's an x all over c squared times 1, which is just c squared. And then that continues for the third term also.